Okay, this section is basically going to be a combination of the previous sections. So we're going back to our old idea, Ki plus Pi plus work equals Kf plus Pf. A lot of you guys were really good at this stuff. You were crushing it. Now what we've done in the last section is we basically took work and we found out what its definition was, which, mathematical definition, which is force times distance times the cosine of the angle. If you haven't watched the previous video, it may be really helpful to do. So what I'm basically saying in this section is, all right, let's kind of put all this together. If I gave you a force, a distance, and an angle, and I maybe gave you the initial kinetic energy and some other stuff, could you solve? So we're going to do an example here. We have a Batmobile. All right. Okay, so we have a Batmobile, and we're driving to the city on a level road, so that's important. That means that's a hint saying potential energy in this problem is not going to save, is not going to change. Don't mind that my little Batmobile is apparently popping a wheelie right now. So originally, the Batmobile, it says, has 2,000 joules of kinetic energy. Suddenly, Godzilla is going to appear. Okay, that's Godzilla's claw. Apparently he's suffering from some sort of tennis injury. And Godzilla is going to kick the car, applying a force of 1,000 newtons for a distance of 30 meters. Okay, and that's going to really get the Batmobile going forward, bombing along here. So I'm going to make that a dotted line, though, because I don't want it to look like a force. And they're asking, what is the kinetic energy now for the Batmobile? So we can always go back to this equation. Ki plus Pi plus work equals Kf plus Pf. And we use this equation every time we're comparing an object in two different positions with two different energies. So we know the original kinetic energy. The potential initial should be 0 because it's on flat ground. We don't know the work at this point. Our kinetic final is what we're looking for, and our P final should be 0 because we're still on level ground. So if we knew the work, this would be a really easy problem to solve for. Some people like to do this two different ways. I'm going to show you the way that most people like to do it, and then I'm going to show you the other guy. So what most people like to do is they like to take this and use it to find the work. So work is equal to force times distance times the cosine of the angle. So work is equal to, all right, force was 1,000, easy. Distance was 30, easy. Cosine of the angle freaks people out a little bit, but it's not a big deal. It says the Batmobile was kicked forward. So the Batmobile is speeding up this way. It's being propelled forward like this. That's its direction its distance is going. And the force applied, well, if you're kicking it forward, the force applied would be in the same direction. And that's the force we're focusing on here. Because they're going the same direction, the cosine of the angle between them is 0. Cosine of 0 is 1. So work is equal to 1,000 times 30 times 1. So work is equal to, okay, so that comes out to 30,000. So now we can put this stuff in. So originally it was going 2,000 plus our work was 30,000. So wow, what a kick. And that'll give us our final kinetic energy. So 32,000 joules of kinetic energy. The other way people like to sometimes do this problem is instead of doing this work separately over here, they like to just straight up put into the equation FD cosine of theta. They like to stick that into this equation. Totally fine. Either way, I don't care. As long as you get the answer and as long as you put a pretty square on the answer so it's easy for me to find, because it's Physics Christmas, the happiest time of year.